Okay, practicing series circuits to start. I'm going to say that series circuits are like the world's worst traffic jam. Or if you've ever been in a school fire drill, um, you're stuck in your classroom, fire alarm goes off, and you have to leave your classroom and go through a prescribed door. You don't have any choice, you have to go out that door. Then you walk down the hall and you have to go through another doorway in the hallway. Then you get to the exit door of the building and you gotta go through that same exit door. Even though the hallway might be big and wide, you can't really go fast through this part because if you speed up, you'll catch up to the people in front of you that are waiting to go through that door, and they can't speed up because they'll bump into the people in front of them waiting to go through that door. Basically, you can't go fast even when you think you can. You can't go fast because you're getting slowed down by those people, or in the case of circuits, those electrons that were in the wires already in front. So basically, a series circuit, the world's worst traffic jam. You can't speed up or you can't slow down. You're just stuck in lockstep moving around this thing. Because of that, what that means in terms of circuits and physics is you have the same current everywhere. There's no junctions. If we have 5 amps get to this corner, all 5 amps go that way. All 5 amps got to go through this resistor. They just keep rolling. They can't Electrons aren't allowed to like stop and have a rest because they don't like each other. So if an electron tried to slow down here, it wouldn't like that because the ones behind it would kind of catch up, and it doesn't want the ones behind it to catch up. So it just sort of stays locked, and electrons all move the same speed, which circuit-wise means they have the same current. There's something called equivalent resistance that we'll work with. Equivalent resistance basically means, I'm going to erase this messy thing. If we've got some resistors in series, one after another. Basically, they we could imagine chopping we could imagine chopping off this part of the circuit. The equivalent resistance would be the single resistor we could replace all three of those with. For series, when it's one resistor after another resistor after another resistor, the equivalent resistance is just the sum of the individuals. So if we have 3 resistors in series, just literally add them up. Remember, resistances are given in ohms, so you're just going to add up the ohms, and when they're in series, add up the ohms, and the equivalent resistance is whatever those 3 things add up to. We're going to pause there, and then we'll apply that and actually solve a numerical circuit.